Okay, time to get started. My name is Mike Niehaus. I am a product marketing manager for Microsoft. For those of you who aren't familiar with Microsoft's job titles, basically the product manager, product marketing manager people are those that are responsible for figuring out what customers need and telling that to the engineering team, and then also to educate people on what engineering actually delivered. In this case, we said that there's such an emphasis on in-place upgrade to getting to Windows 10, we need some more in-depth content explaining how this thing works. It can't just be a black box. So we had to go to the engineering team, the program managers who designed this, and told them, we'd really like for you to create a session for Ignite in Chicago this past summer that explains this. Of course, the program managers know here's what the specification said it was supposed to do. Then they hand it to the developers who actually write the code to make that work. So combination of the program managers and the developers created the content that we're going to go through. I now get to explain it to you. And of course, they decided that they would start off with something cute. Let's use the analogy of an egg to explain the upgrade process, where the operating system is the yolk in the center, and the apps, the data, and the settings are the whites around the outside. So the in-place upgrade is kind of like removing the yolk and dropping a new one in without disturbing the whites, which, if you've ever tried to do that with an egg, you know that's not a particularly easy process to go through. So I'd like to think that they could come up with a better analogy, but it's a starting point at least. We at least have a reasonably bulletproof egg that we're going to be able to lift the operating system out, move it off to the side, drop a new one in its place, and keep everything else around it intact and working. So that's what we want to talk about. We want to explain how we can do that and what's going on behind the scenes. In a lot of cases, to really see this in action, you'll see some visual clues as to what's going on, but more of it is in the log file. So we'll take a look at some of the logs as we're going through this as well. We're trying to really get you comfortable with an in-place upgrade because we're changing the way we deliver Windows to give you more functionality faster. We had some of this discussion yesterday. We'll continue to have it throughout the coming months, but the idea of Windows as a service, we're going to release Windows more often to come out with new features more often. So as a result, we want you to be able to deploy this more easily. And to do that, we really want to move away from the traditional wipe and load deployment that most of you have probably been doing for the last decade to an in-place upgrade. Wipe and load, everyone understands. You capture the data and settings using USMT. You lay down your own custom image, inject drivers into it, reinstall your apps, and then restore the data and settings back on top of that. You've been using MDT, Config Manager, and other tools for years to do that. We have some new capabilities with provisioning, which is all about setting up new devices. But then in the middle, we have the in-place upgrade. Behind the scenes, this is really going to do a very similar process to what the traditional wipe and load would do, except Windows itself, the setup program, is going to do the work for you. It's going to automatically preserve all data, settings, apps, and drivers. Basically, it's going to preserve everything that isn't part of the OS. It knows the OS files, the OS registry entries, everything that it knows as part of the OS. It will move off to the side, lay down a new OS, and then keep all the apps, data, and settings more or less in place. As we look through this, we'll see that it's actually moving some things around as part of this process, but more for convenience than anything. But most of the folders, most of the files related to the applications and the data that you have on the system right now are left untouched. It's just a new operating system being deposited. So there are a variety of concerns on reliability and the performance and how long this takes, and does it result in an operating system that's as good as one that's been deployed using wipe and load? And generally, we would say yes, that if you had an operating system that was working well and applications that were working well on the old version of the OS, running Windows 7, and then you upgrade it to Windows 10, the expectation is those apps will be just as happy as they were before. The OS will be working just as well, if not better than it was before, since we've laid down a new operating system. So that's kind of what we had to prove. What we're encouraging most customers to do is try this. Take a collection of machines, use the in-place upgrade them to Windows 10, and see if you encounter any issues. For the most part, it should just work. There are always a few little gotchas with some older versions of apps that hook into the OS at a very low level, especially old VPN clients, old firewall software packages. Most of the current ones that truly support Windows 10 have been updated to take into account this in-place upgrade. They followed the rules and guidelines that we provided to the ISVs to make sure that their products can hook in at the right place and that the upgrade process can migrate those forward. We've made a lot of enhancements in the Windows 10 upgrade itself to make sure that works, especially things that are hooked in deep into the networking stack, to make sure we migrate that forward properly into the new OS. So what we want to cover as we go through and dig into this in more detail is the upgrade process and the 4 phases that are involved in that. Some of the eligibility and compatibility checks that we're doing as part of this, the inventory and migration steps that we go through, and what happens if something goes wrong, because we need to be sure if anything goes wrong during this process, we don't leave the machine in a bad state, that we can take it back to the original operating system and the user can keep on going with the original OS and you can troubleshoot and attempt it again at some later point in time. So let's talk about the upgrade phases. In-place upgrades are always going to start from within the current operating system. You don't boot into Windows PE and then start an upgrade. You boot into Windows PE to do a clean install, but to do an upgrade, you need to run this from within the current operating system. Windows 7, Windows 8, Windows 8.1. From there, we can do things in this down-level operating system. The down-level OS is up and running. We can extract settings, we can extract configuration from that. That's what happens in these initial phases, where we can run compatibility checks, then we can gather information about the current OS before we start the deployment process, before we start the installation. So you'll see this happening in the old OS. Unless you're using MDT or Config Manager, because most of the time with those, you completely suppress that UI. So all you would see is a task sequence progress dialog and then a restarting message to indicate that you're restarting into Windows RE, which is a customized recovery environment built on top of Windows PE, to start laying down the new OS. So that's the first phase. Compatibility checks, verifying the environment, capturing information from the old operating system, then rebooting. At that point, we're in Windows RE. We're in this customized Windows PE environment where we can do the actual copying of the new OS in place. So we had to move the old operating system out of the way, which will get moved into the windows.old folder on the hard drive, and then we'll lay down a new operating system image. This takes a little bit of time to lay down that new image, and it consumes some disk space. So there are some minimum disk space requirements in order to complete this in-place upgrade. Once we get through the Windows RE phase of moving the old OS into Windows.old and laying down the new operating system image, we boot into the new operating system for the first time. This first boot enables the OS to specialize itself, just like a normal OS would, and it restores all the settings that were captured earlier. It puts all the components back that were installed in the original OS. So if you'd enabled optional features in the original OS, we'll make sure those same optional features are there in the new OS. We'll inject drivers. We'll do the standard plug and play identification of what drivers are needed. We'll migrate forward what drivers we can. We'll pull newer drivers from the image that we're installing. And we'll even go out to Windows Update and pull down new drivers where we see that there are newer drivers that would work better. After that whole process happens, we can reboot one more time and then be in the new operating system, really for the first time that it's designed for the user to be able to log in and complete the process. So we go through the final configuration, the final cleanups, and once we get through that process, the user can then log on, and you can go through the standard UBI process, where it would ask you, do you want to use your standard settings? Do you want to, there's a variety of questions that it asks during that UBI process. Again, because most of you would run this via Config Manager or MDT, you would suppress all those user interface choices so that all they would see is really this circle during the upgrade process. And once it's complete, it leaves them at a login screen where they can log in for the first time. When you log into the OS for the first time, you see the pulsing colors, just like you did in Windows 8 and Windows 8.1, where it will install the apps that need to be installed per user. So that first login does take longer than subsequent ones, but that process is what happens at the end of the upgrade. So at the end of the upgrade, you see the notification, welcome back. You can accept the settings that are available. You can get some notifications on what's new. So some basic information. Those are the screens that most enterprises would suppress, and then you're ready to sign in. So those are the 4 phases. That's really what we go through. Now we need to dig into each one of those in a little bit more detail to see what's going on. Before we talk about that, though, I did want to point out the logs that are being created through this whole process. So if I were to look at my laptop, let me switch over to that for a moment. I upgraded this to the latest Windows build last night from my hotel room. If your internet connection was slow, blame me. I was downloading a new version of Windows. That build was installed. It went through all 4 of those phases, and during that, it created a log file, setup.act.log. If we were to look at a Windows PC that's gone through the upgrade, you will see this $Windows ~BT folder. That's a folder created by the upgrade process. And if we look in the sources Panther folder and scroll down to where I can actually see this, the main log file setup.act.log. We can see that log at this point was about 40 meg. So the first parts of the process that run in the original OS are there. Once it reboots, it will eventually move this file into the Windows Panther folder. So you'll see that after a point in time, it stops writing to that, and then it starts writing to Windows Panther setup.act.log. And now the log file has gotten much bigger. It's up to 260 meg at this point. So that's the continuation of the process. And then when it gets to the final stages, where it's doing those out-of-box experience first run prompts, it will create another one in the unattend GC directory called setup.act.log as well. So if you want to follow the whole process, you can either just look at the Windows Panther setup.act.log or look at the $Windows ~BT and then go to Windows Panther and then into the unattend GC. But really there are 3 different versions of the file that you'll find on a system, and they're useful for looking at different parts of the process. So in this case, I've grabbed them and I've just gone through and made various notes inside of them just so that I could see some of the operations that were happening. Because otherwise scanning through this thing in real time is difficult because it is huge. So I've marked a place where it's starting to do the first phase, the down level. It's starting to do some of the verifications. So we'll continue to go through this and look at different sections of it as we're talking about them. But if you really want to know what's going on behind the scenes and you really want to waste a day, read through this log file and figure out what's happening. It's all in there in very, very verbose logs. So definitely read through it and it will give you some deeper understanding of what's going on, or at the very least, deeper confusion about what's actually happening behind the scenes. So down level, let's talk about the details that are going into that, then Windows RE, then the first boot, then the second boot. First and down level, we will be running in the current OS. We'll check the system to make sure it meets the minimum requirements. We'll collect an inventory of applications, drivers. We'll compare that against a compatibility database. So included in the Windows media is a compatibility database that says if you encounter these models of machines, these BIOS versions, these app versions, these driver versions, stop the process. We would call those hard blocks. These hard blocks are to prevent us from getting into any trouble. If we know that there are things that have compatibility issues, there's no need for us to continue farther into the process just to prove that the process is going to fail. So we will have these hard blocks that will stop the process up front. If you've ever seen the dynamic update process that happens during this initial down-level phase, what it's actually doing is going out to Windows Update and finding the latest compatibility database and downloading that and using that instead of what was included in the original media. So it's constantly updating that database to give you the latest details. It will also go out and download the latest cumulative update for Windows 10 so that the machine is pre-patched before the upgrade actually runs. So if there's a bug that caused any issues, we can apply the patch that fixes that bug before we even install the OS. So all of that's happening in the down level part where we're doing that dynamic update. Once we've verified that everything is okay, that the image is in place, that we have the drivers and the updates that we need that we pulled from Windows Update, we can then prepare Windows RE and reboot into that new OS. So when we're in Windows RE, it is your standard Windows PE environment, not very big. The new operating system is in a folder on the hard drive under that $Windows ~BT sources new OS folder. So the new OS has already been applied to the disk, so it's taking that additional 8 gig or so of disk space, which is why we need about that amount of free disk space. The old OS is still in its original location, so nothing's been done yet. At this point, we can take the old OS and move all the conflicting folders between the new OS and old OS into Windows.old. Folders like the Windows folder, the users folder, program files x86, any of the root level folders that conflict with what's in the new image. Once those have been moved into Windows.old, we can then move the new OS from the new OS folder to its rightful location at the root of the C drive. All of this is just hard link manipulation. It's not actually copying any files or moving anything at all. It's just creating new links in the right places. So it's a bunch of pointer operations, basically. Once all that's been done, it can inject drivers and do some migration processes, really to put all the other pieces of the OS back into the right place. So imagine it's taken the old Windows folder and moved it to Windows.old and then put a new Windows folder down. Well, that new Windows folder doesn't have all the same files that were in the old Windows folder. Even though we tell apps don't put things in the Windows folder, they do anyway. So as part of this migration process, we have to identify the extra files that are in the Windows folder, in program files, in the users folder, wherever they happen to be, and hard link those back into the right location. So there's a lot of manipulations going on during this to make sure that all of the files that were in the original locations are still there before the operating system boots up for the first time. We can then boot into the new OS. So we've got a new yolk in place now. We can make our egg come to life. That specializes the machine, installs the drivers via plug and play, migrates the apps, which at this point is more about the registry entries and the details of the applications, and then migrate the operating system settings as well. So all the different components all have settings associated with them. They were captured from the original OS. Now they can be put back into the new OS. For some things, that's really simple. For others, not so much. Like if you are running a developer workstation on Windows 7 with the version of IIS that was available on Windows 7, and now you've moved to Windows 10, you can imagine that there's a little bit of transformation that needs to be done as part of that migration to translate the IIS settings from Windows 7 into the IIS settings for Windows 10. The components themselves, in this case IIS, know how to do that. There's specific code provided with each component that understands how to translate older settings from older OSs into the newest OS versions of those components. Once all that's done, we can boot into the new OS for a second time. Now at this point, the OS is completely ready. All the apps are put back, all the registry settings are put back, all the drivers are in place. We can then welcome the user back, which is the part that you would most likely suppress, and go through the UBI process, which again, you would likely suppress. Ready, set, go. That's pretty much what we're doing. We're trying to get ready in the old operating system. We're setting the new OS in place in Windows RE. We then boot into the new OS, and it's finally ready to go on that second boot. So let's look a little bit more at the down level part, where we're performing system checks. We need to make sure that the minimum CPU requirements are met. That's not a big deal, as there aren't any significant items as far as speed goes. There are some specific instruction requirements that were added in Windows 8 and Windows 8.1 for 64-bit OSs. We require certain processor features and instructions. So if you're running Windows 7 x64 on really old Pentium D hardware, the CPU compatibility check will complain to say that this CPU doesn't include the necessary instructions to run Windows 10 x64 on that particular CPU. No need in proceeding any farther. We'll abort at that point. Fortunately, that's like 0.001% of the machines out there don't include the instructions necessary to run that. And even in those cases, well, you could run the x86 version without any issue because those instructions aren't used for x86. So we do CPU checks. We do some RAM checks just to make sure that you meet the minimums. Windows 10 still requires 1 gig for the 32-bit OS and 2 gig for 64-bit OS. Standard minimums, those haven't changed since Windows 7. We'll check to make sure that there's available disk space, first to do the installation, but then also for the recovery. We know that we're going to lay down a new 8 gig or so new operating system image to the disk. We're then going to have that windows.old folder that remains around. And there's some manipulations that go on during the installation and in the rollback process. So we'll have some extra buffer in there as well. So it will check to make sure that there's enough disk space in place before continuing. It will make sure that there are the necessary critical drivers in place. It really does no good to complete an upgrade if you don't have a mass storage driver that's needed for the new OS to actually access the disk. That would instantly blue screen. So that would stop the process. So storage drivers are very critical. And because in a lot of cases you're pulling the components from a network path, making sure that you have network drivers in place is key as well. There are other checks that we perform just for some unsupported scenarios. We don't support in-place upgrade for Windows to Go. So if it finds that this is a running Windows to Go USB stick, it'll stop. Nope, you can't do that. It'll make sure that you're not using boot from VHD. You can upgrade a VM, that's no problem. But if you're actually using the native VHD boot capabilities to boot a physical machine from a VHD file, you can't upgrade that as well, so we'll block that. If we find a UEFI machine, we'll make sure that it's running at least UEFI 2.3.1, the minimum version for Windows 10. So we're doing all of these types of checks just to make sure we don't get ourselves into too much trouble. On the storage side, most systems will have plenty of disk space. So no issue. You've got at least 8 to 10 gig of free disk space. We just continue on. There are some scenarios where there is limited disk space, though, where you're right on that borderline. And we will take some specific actions in those cases to try to optimize things. We'll compress the OS. We'll make sure that we're not keeping anything extra on the machine than what we absolutely have to. So you will see some slight changes in behaviors if we see that there is not enough disk space available. Where it gets really interesting is machines that don't have enough disk space at all. If you're talking about my laptop, which is, I think it's got a 160 gig hard drive in it, and I'm constantly filling it up. All right, I can free up enough disk space to go through the upgrade process. So this isn't really designed to solve my problem, although it certainly could. It's really designed for that Windows tablet that only shipped with 16 gig of storage on it in the first place. How do you upgrade a machine that's running with 16 gig of hard drive space when Windows, when it was installed initially on there, probably took up over half of the drive already? So you're going to have less than 8 gig of free disk space from the start. And then you patch it and install apps and add data files and do all these other things to it. And you probably get to a point where you've only got 2 or 3 gig of free disk space at all. In that case, we added support in the upgrade process to ask for external storage. We need to preserve that old OS. We need to keep that windows.old folder around. We will copy the OS off to USB storage, then remove the old operating system from the current drive before we lay down the new operating system, and then we can migrate back the missing pieces. So as a result, the actual delta in disk space needs on that machine is 0, because we're leveraging the external storage to make up for the fact that the hard drive on the machine doesn't have enough disk space. If you're trying to do this automated using MDT or Config Manager and pushing out setup.exe/auto upgrade, you won't see this happen. You would only see this via Windows Update or if you're manually running an upgrade. So you may see on some of these machines you need to manually upgrade them in order to go through this external storage scenario. We also will automatically compress the OS as it's being applied to the disk. We're using a new compact OS option. We talked about that a little bit yesterday. It used to be called WimBoot. We've enhanced it in Windows 10 so that the OS itself can be compressed and stored in effectively a single hidden file on the machine to get rid of the lost sectors because of all the small files that are present in Windows, to get rid of duplicates, to compress the files down to their minimum size. So we can take that 8 gig footprint and shrink it down to somewhere around 5 just to free up additional disk space on these systems as well. If you have one of these 16 gig tablets, they probably shipped with Windows 8.1 using WimBoot, which had a different partition structure and a different disk layout where the OS was stored in a WIM file on a separate partition that was read-only, and then there were pointers on the main C drive that pointed into that WIM file. It was all transparent to the end user. When we upgrade it, that additional partition isn't needed anymore. It's not used with the Windows 10 implementation. So after the 30-day rollback period has gone by, we'll then get rid of that old recovery partition containing that image and expand the C drive to take up the rest of the space as well. So we're doing as much as we can to optimize the disk space and to make sure that it's as easy to deploy even on those smaller devices. We'll inventory the hardware and the drivers. We'll do some matching between them. We'll look at plug-and-play IDs. We'll look at drivers. We'll make sure that we have compatible versions for all the different plug-and-play devices that are on there. Applications get to be a bit more interesting because, well, you've probably seen all the different types of installers that are out there. There's no consistency at all in these applications, for the Win32 desktop apps, when they install on a system, the best that we can hope for is that they all consistently put themselves on the programs and features, add remove programs list. So for us to figure out what applications are there takes some skill. We had to run through some heuristics to identify the applications based on the presence of files or registry entries or other types of heuristics that are built into setup. And then we can use that resulting list to check it against the compatibility database to look for issues. So we're looking at this application inventory primarily just to figure out what might not be compatible. We're not looking at this to figure out what to migrate. We're going to migrate every file and every registry entry that we find on that system that we know isn't part of the old OS. So we'll move it forward anyway. You create a text file in the Windows folder, we'll migrate it. You create a random registry entry just to see if it gets migrated. It will get migrated. We can't take any chances on the files and registry entries that we find on the system because we don't know for sure if they're needed for any particular application. So we'll migrate them. But we do need to do the compatibility checks against the application inventory, so we're using heuristics to come up with that list. So we already talked about that. It's on the media. We're continually updating it. And we want you to use the dynamic update capabilities to pull the latest version of that down so that we can compare against the latest details. So we'll go through the inventory. We'll check each item that we find. We'll take one of 4 actions. Either migrate it, don't migrate it, block it, or prompt the user. If we don't migrate it, there are applications that we can just drop during the upgrade process. They'll just disappear. They won't be present in the new OS. It's not very common, but we know that these applications either cause significant issues with the new OS or aren't needed in the new OS, so they will just get quietly dropped and left behind. For ones that we block, we figure that those are apps that you probably want and need. We know that there are issues with them in the new operating system, so we better tell you about those. So for those, that would cause a failure of the upgrade process. It would report back that there was a compatibility issue and give you the ability to remediate that and try the upgrade again later. There are a few items that are kind of iffy, though. There are some issues that we know about that aren't the end of the world. That maybe an application after the upgrade requires updating or requires reinstallation or something like that. So there are soft blocks in place as well. Those soft blocks really will just prompt the user and say, we found these issues. Do you want to proceed anyway? A good example of that one is Media Center. Windows 10 doesn't include Media Center anymore. So if you've got a machine running Windows 7 with Media Center, and you want to upgrade it to Windows 10, hey, we should tell you that after you go through your upgrade, you won't have Media Center anymore. If that's okay, click OK to continue. If you don't like that, well, then you better abort. So we do have those types of soft checks in there as well. When enterprises run automated upgrades and you say setup.exe/auto upgrade, most of the time you would ignore those soft blocks. You would just get failures back on the hard blocks, because we don't want to throw up any UI during that process. For drivers, we migrate all drivers by default. There are some exceptions to that. If we find that there were some in-box drivers from the original OS or some incompatible drivers, those won't get migrated. If we find some that are incompatible, that can block the upgrade. But in most cases, we should be able to go out to Windows Update and pull down the latest needed drivers if they're not included in the new Windows 10 image. For applications, we migrate everything by default. We can even remediate issues during the upgrade. So if we find an application that's incompatible and it needs a shim in order to work, if you've ever gone to Chris Jackson's app compat sessions, shimming's just a way of fixing issues in applications by changing the behavior of the OS to match what the app expects. We can apply shims to the apps as part of the upgrade process. There are a few apps, like I mentioned before, that we can drop, that we don't migrate during the upgrade process. And there will be additional soft blocks where we'll prompt the user to ask them what they want to do. At that point, we need to do some migration on the operating system itself. The OS is composed of components. There are over 10,000 components in the OS. They're all self-describing. They all have a manifest that says this component is made up of these files, these settings, these registry entries, and these migration modules. So they can run custom code to perform these migration operations during the upgrade process itself. IIS is the good example, but any component of the OS can do any type of manipulation during these upgrades that are needed to take into account the changes between the different OS versions. We'll gather information in the down level phase, and then that information will actually be applied in the second, third, and fourth phases. So it's a collection process initially, and then it's acted on later in the process. If you pay close attention, when you upgrade from Windows Update, if you're doing more of the consumer scenario, and you see that there's a new build available through Windows Update, and you click to reboot as part of the installation, it doesn't actually start the capturing process, the gathering process in the old OS until it's logged you out. You'll see installing updates message, and it'll have a % counter. It's not really installing updates. It's really going through this migration process to capture that information. It's better to do that when no one's actively on the system, because if they made any changes to the OS configuration while that process was running, we might miss those configuration changes. But if you're doing this via MDT or Config Manager, and you say run setup.exe/auto upgrade from a task sequence, and there's a user logged on, okay, fine, we'll go ahead and migrate all of these settings while the user's there. There's just a small risk of them tweaking something, and that tweak is missed because it was already captured by an earlier part of the process. So once we're in Windows RE, we know what we want to migrate, what we want to leave behind. We've downloaded the drivers that are necessary. We've downloaded any additional cumulative updates that we want to apply to the OS. We've injected that cumulative update as well as boot critical drivers into our recovery environment, just to make sure that we can still access the machine. We boot into Windows RE, and then we start shifting things around. First, moving the old OS into Windows.old, and then putting the new OS in place and starting all these migration tasks. Let's look at a little bit of the log file here just to show you the types of things that are going on. So we showed before that we start the phase 1. Oops. Helps to be able to see. We go through compatibility checks. So we start gathering inventory. When you see these Windows Compat Appraiser checks, it's basically going through and identifying the apps. It's checking the UEFI firmware. It's done a variety of checks there. Then it has to figure out how much disk space do we need, how much disk space is available, so it goes through a variety of calculations. You'll see references to this Safe OS folder, which is where the new operating system is going to be placed. It will then start checking for dynamic updates. So you'll see it goes out and tries to find GDRs, which are basically general distribution releases, the standard updates that are published to Windows Update. If it finds any, it will download them. Now, since I'm running the latest Insider build here, there weren't any, so it didn't find any to download. But if you were installing the standard Windows 10 released version, it would always find one and download it. About a 300 meg update that it pulls down. So it goes through that process, and then it looks for drivers. So in this case, on my laptop, it identified drivers that it knows that there are better versions available in Windows Update, so it goes and grabs those. for printers, for other devices that are attached to my system. So it will build that list and gather those together for this particular machine, download all of them, and once that's done, now those drivers are staged and ready for the next part of the process. It mounts the WinRE.Wim, that Windows PE image that it's going to boot into, just so that it can inject any critical drivers into it. So you'll see it go through that process. It periodically will log the operations that have been completed. So as it puts an asterisk next to each one of these, we can see what it's done already. So it's extracted files from the WIM into the SafeOS folder. It's mounted the Windows RE folder. It's made sure that the safe boot is in place. It's saved entries for the old OS. And then it will continue on through all of these other operations as well. It goes through migration process for drivers, so a significant portion of the log is dedicated to driver migration. And then it goes through settings migration. If you've ever looked at the log file for USMT and compare it against the log file for the in-place upgrade, you'll see that they're very similar because it's really the same engine, the same code being used for both of them. It's just using different heuristics. In the case of the in-place upgrade, it's doing more work to identify apps and to identify drivers and those types of things, where USMT is primarily concerned with migrating registry entries and file contents. But it is the same engine behind the scenes, so a lot of similarity between the two. It will also figure out what modern apps need to be migrated, which universal Windows apps. So it will see that the apps are currently present on the system and then figure out for those which ones need to be migrated and which ones will be taken care of because they're part of the new OS. We don't need to migrate it if the new OS has a newer version of that app already built into it. And then it does a variety of storage migration. So we'll skip over some of that, because it just happened to use the same text as I'm keen on. All right, finally done with the migration process. Almost time to reboot, so it's basically made sure that it has enough disk space, that everything is in place, ready to go into Windows RE. And then toward the bottom of the file, it finally says, okay, reboot the system. So requesting a reboot. So that's all the first phase of the process. Second phase then, we're offline in Windows RE and we're making sure all the components are put back. So you'll see it going through and making sure that all the features are installed. It'll add IIS if it was used before. It'll add any other optional component if you had installed it before. So it puts those back. It applies the drivers that had been gathered before, the ones that have been downloaded from Windows Update and migrated forward from the old OS. Then it starts moving the old OS out of the way. So the old OS ends up in Windows.old. We can see it's actually higher above in the file where it starts moving those files around. I mean, it might actually be lower. Let's see what's down below. Yeah, so here it's starting to move C Windows to Windows old Windows. It moves program files to Windows old program files x86, users, program data, inetpub, recovery, basically any folder that conflicts with what's in the WIM that's going to be applied. Once it's done that, now it can start migrating settings into the new OS. Everything's restored. Now it's time to boot into the new OS. So that's basically the first two phases of the process. It's a lot of information, a lot of detail in there. So the biggest challenge with reading through these is to sift through the detail and figure out what's actually important. For the developers and the support people who may use this for troubleshooting, they would say all of it's important, but for most of you, including me, you would look at this and say, yeah, there's about 1% of this that's actually interesting and the rest is just noise. Don't pay too much attention to the warnings and errors. What are considered warnings and errors in these logs aren't really things that are fatal to the overall process. They're just logged that way primarily to get people's attention when they're looking through the logs. So going back to the process, we were in Windows RE, we've got the new OS in place, we put the drivers in place, we've migrated all the settings into this new OS, we're ready to boot into the OS. So we'll reboot into the OS for the first time. It goes through specialization and injection of the drivers from the driver store. And then we can boot into the new OS to go through the final touch-ups and through the out-of-box experience, the UBI process to do this. And that really continues on with the second piece of the log file that we were looking at before, where it has shifted into the Windows Panther folder instead of the $Windows ~BT folder. And that's one of the fun parts because this log file effectively picks up where the other one left off and contains a lot of the same information. So we had to skip over the same things that we were looking at before. Which is not much fun. Next time I do this, I won't use equal signs. I'll use some other random character. So okay, at this point we can see that we're finally in the new OS. We're beginning the specialization process. It confirms that we're running from C Windows System 32. We're getting into the setup process as part of UBI, and we'll go through the driver installation and other things there. We'll create components. We'll go through all of the standard sysprep specialization work. Then we'll migrate settings, the last of them, into the new operating system, including more storage settings, which I don't really care about. And then it starts putting the extra stuff back. So we'll notice that it's finding files in Windows.old program files x86 that aren't in the new operating system image. So those must be needed by some application. I'll go ahead and put a hard link back. In this case, I've got a utility app installed to configure a Netgear wireless access point. So it found that and it said, okay, I need to move that, or move really is just create another hard link, back into the original location. So it will go through all of these extra files in program files, then in program data, then in the Windows folder, in the users folder, in all the different registry entries. And it goes through all of those and just starts putting things back to where they need to be. That goes on for quite a while because there are a lot of extra files. None of these are actually being copied. Everything is being done by the hard link process. You can also see as it goes through here that it starts to migrate user accounts. So I can get to a point where I can see it migrating my actual user settings, which it has saved as part of the migration process. It will then start putting back all of my files as well. So as we go through this, we see all of this happening as part of the log. It's finally then finished migrating stuff, and it's ready to reboot again to continue the final UBI process. At that point, it actually shifts into the third log file, the setup act.log in the unattend.gc folder, where it will start processing UBI. And that's the last message in there, because after that, basically, it's just going through and displaying the wizard panes. But since I did an auto upgrade, it didn't ask anything. So it basically just said, yeah, I took all the defaults, and the process is now done. We actually had a couple of customers ask last week, how do I know if the upgrade was successful? Which was a puzzling question, because we looked at it and said, well, if you're running Windows 10 now, the upgrade was successful. So Why are you asking this question? Well, they want to be able to look at the log file and be able to prove that the upgrade was successful. Okay, here's the line that proves the upgrade was successful. There is a single registry key on the system that indicates the state of the operating system. That is left set to image state undeployable during this whole process until it's done. When it's done, it's finally set to image state complete. At that point, the operating system is ready to run on its own. So that's when it's done. Why they want to be that picky about it, I would just look at it and say, is it running Windows 10? Yes, it's done, but they wanted to check. So all of that is in the logs. You can certainly check that out and follow along in the process. So one last thing then. What happens if something goes wrong? We need to make sure that we're recoverable wherever we're at in the process. So we talked about the 4 different phases. We need to know what happens to recover in any of those phases. In the down level phase, the old OS is still running. All we're doing is gathering stuff. All we really need to do in the case of a failure is clean up. So we'll terminate the processes, we'll write out the log files, and we'll go away. There's nothing else really that needs to be done. If we get farther into the process, where we booted into Windows RE, into Windows PE, if there's a failure here, the old OS is still in its original location. The new operating system is in the $Windows ~BT sources new OS folder. So we need to do some cleanup on that. We need to change the BCD back to point into the old operating system. But otherwise, we just do some simple cleanup and boot back into the original OS. So that's not too bad. When we get to the first boot, it's a little bit more interesting because at this point, we booted into the new Windows 10 operating system. And the assumption is something happened. You've seen that error message. We probably made fun of it, but something happened. That's the best that we can tell. If something goes wrong in the first boot, we need to make sure that the machine boots back to the recovery OS. So it actually leaves the BCD pointing to the recovery environment. So if there are any blue screens, any failures, you pull the power plug, whatever happens to the machine when it does that first OS boot. If it doesn't get through that whole process, it will fall back to Windows RE again on the next boot. It'll boot into PE, and it will recognize that something went wrong. I need to put things back to the old OS. So there's a little bit more work involved now. We need to reverse the changes that we've made. So we've got that windows.old folder. We've put the files at the root of the C drive. Well, at this point, we need to remove them from the C drive and then move the folders from windows.old back to their original location. Then we go through the same cleanup process of getting rid of all the temporary stuff and reboot to the old operating system. If the failure happens during the second boot, it's the same basic process. We have the BCD pointing back to the recovery image, just in case. So if the machine blue screens, it'll boot into Windows RE, it will see that something went wrong, and it will revert all the changes the same way that we described before. So it will take windows.old, it will put it back to the original location, it'll fix up the BCD, clean up after itself, and then boot back into the original operating system. That's a really interesting scenario because I've seen instances where I've had problems with software on my machine early in the development process. So it went completely through the in-place upgrade process, and I'm sitting at the login screen. It shows my username and just wants me to type in my password or my PIN. So I put in my password, click OK, machine blue screens. At that point, it rolled back to the old operating system because it doesn't do the final cleanup until it proves that someone can actually successfully log on to the system. If you can't log on, even though the upgrade was successful, it wasn't a useful system. So it leaves this recovery process in place just to make sure that someone can actually log on for the first time. After that, it will do the cleanup to make sure that we're now permanently in this new operating system. But That's a really weird experience where you see, oh, I've been upgraded. I log in, it blue screens, and oh, I'm back to the old OS again. Better than having repeated blue screens every time you try to log on to the system, but it's an interesting case. So then the question is, well, what about days later? Let's say I've gone through the in-place upgrade. Everything went smoothly. I logged in. I'm using Windows 10. Everything looks fine. I get to a point where I try an app and it doesn't work. Or I can't use a peripheral, or something else isn't good, and I want to go back to the previous operating system. I want to go back to Windows 7. You can do that. You can actually go into the settings, into the recovery process, and say, roll me back to the old operating system. And it will initiate this same rollback process as the second boot. It'll boot into the recovery operating system, that Windows RE environment. It will reverse the changes by getting rid of the new OS from the C drive, moving things from Windows.old back into the original location, clean up any mess that it left behind, and then reboot into the old operating system again. So it leaves Windows.old around just for that purpose. If you want to, within the first 30 days, roll back to the previous operating system, you just go into settings and say rollback, and it will go back to the previous OS. That assumes that you haven't manually cleaned up the Windows.old folder. So if you delete that, which is actually rather hard to do if you try to do it manually, but there's a disk cleanup wizard. If you run the disk cleanup wizard and tell it to remove old versions of Windows, it'll pop up a warning dialog that says, after you do this, you won't be able to roll back to the previous OS. Well, that's because you're removing Windows.old, and as a result, you can't roll back. We'll also automatically clean up Windows.old after 30 days. So 30 days later, we assume that you're probably happy with Windows 10 by now, and you've probably made enough changes in the new operating system that rolling back to that old one that's 30 days old is probably not an ideal situation either. So you're probably going to continue forward and try to fix the issues rather than roll back and try to deal with them later. So it will be kept around for 30 days by default. There's basically a maintenance task that runs after that will automatically clean it up and free up that extra disk space that it's taking up. Again, it's 8 to 10 gig of extra disk space. It's primarily the size of the new operating system. Since it is using hard links for everything else, it's not any bigger than that. So that's the point. You can uninstall for a limited period of time, 30 days by default. As long as that Windows.old folder is around, you can roll back. So that's what I wanted to cover. Are there any questions related to this whole process? Right. Yeah, we're working on that process right now. The basic question was, well, what happens if you're doing this in-house with MDT or Config Manager, and is there a way that you can point to an internal location or manually update the media? You can certainly manually update the media by injecting the latest update into the install.wim yourself. So download it, mount the WIM, install it, because that's basically what the upgrade process will do itself. We're still working on some instructions on how to update the compatibility databases manually, but the other scenario that we want to enable that isn't quite there yet is to use WSUS to pull those pieces. So if you've got a WSUS server, it can hold that dynamic update content. So that might take a couple of weeks before we get that in place, but that's something that we're working on as well. There are some options in Config Manager and MDT to enable dynamic update or to disable it. It's disabled by default in the task sequences that are provided with those, because you probably don't want 10,000 machines going out to the internet and downloading 300 meg patches and 100 meg of drivers. So it's off by default, but you could turn it on to enable that. But we are still working on the WSUS scenarios to help with that. Yeah, so the question or the comment was that during the upgrade process, some of the drivers don't get migrated. Do we get to see that information? And the answer is yes, kind of. It's in that log file. It's just really hard to find. So you will be able to find what drivers were skipped. Some will be skipped because of their driver class. Some will be skipped because of the specific plug-and-play ID or the driver version, but those details should be in the log file. It's just not the easiest to find. What does it do with IE8? Well, obviously it's not going to do anything with IE8. It's going to leave you in an operating system, Windows 10, that has IE11. But the IE components in the OS do know how to migrate the settings from IE8 to IE11, so you will get your settings migrated forward, like security zones and home pages and proxy settings, and all the other things from the old OS would be migrated into IE11. With that said, I hope you're not going to be in that particular scenario, because if you were in Chris's session right before this, end of support for IE8 on Windows 7, which is probably what most of you are running today, ends in January 2016, which isn't that far away. So you need to get to IE11 on Windows 7 probably before you get to Windows 10. So step number one to migrating to Windows 10, get to IE11, and then it's IE11 to IE11. Then you can leverage all the enterprise mode capabilities to give you all the migration and mitigation capabilities from enterprise mode in IE11. Okay, with that, I think we're out of time anyway. If there are any other questions, come see me up front afterwards. Hopefully that was a useful overview, and I've got another session this afternoon.